Hi everyone, and welcome to the Future of Cooling Efficiency with the CWX and XL series. My name is Leon Mini. I'm the product manager for Climate Wizard, and I really appreciate you taking the time out of your busy schedule to attend today's event. I'm sure that the information that we'll be sharing with you today will add to your stable of products to help you meet customer requirements in current or future projects. I'm joined by Blair Zane, the head of commercial sales with around 15 years of HVAC experience. Also, Danny Hages, the project manager, or rather the mastermind behind the CWX XL series. Danny is from our Imagineering team and has been with Sealy for around 10 years on various innovative products.
Hi, everyone.
Hi, everyone.
So just a quick note before we get started. At the bottom of your screen, you should have a little Q&A box allowing you to ask questions during the webinar, which we'll attend to towards the end of the presentation. Also, once the webinar is ended, you'll be prompted to complete a 3-question survey. This should really only take about a minute of your time. It consists out of 2 questions with yes/no answers and 1 open text box to provide feedback, share your opinions, raise additional questions, or anything that you would like to share with us. Now, we have quite a few people today on the webinar, and it's great to see both new and existing customers joining us. For those new to Sealy International and Climate Wizard, I'll cover a brief company overview, and then I'll hand it over to Blair to provide some information about Sealy's advanced indirect evaporative counterflow heat exchanger, as well as share some key market insights. From our existing customers, some of this information might be already be familiar to you. However, we invite you to celebrate the shared success. Sealy International would not have been where it is today without your continued support. Thereafter, Danny will take us through the CWX and XR series, providing more detail to its development, its capabilities. We'll cover features and benefits. We'll look in some performance data, as well as we'll finish up with a few pre-launch installations. These installations will provide real-life examples of how this product has performed in field over the last 20 months. Should you want more information about these trial installations that we've done, please make a comment in the question and answer box, and we'll get that sent off to you. So let's get started. Sealy International began in 1972 by Frank and Kathy Sealy. It's a business with 53 years of extensive experience in HVAC innovation. This family business has really grown from humble beginnings to become an Australian icon, one of Australia's largest air conditioning manufacturers, as well as a global leader in HVAC, developing innovative, energy-efficient cooling and heating products. Our vision is one that places innovation at the forefront, quality at the center, with an outcome for the greater good, greater at energy efficiency, better for sustainability, and better for health for every person that breathes the air our products produce. This all is packaged into a solution that redefines what is possible with efficient climate control solutions, delivering measurable impacts for people, businesses, and our planet. Today, more than 80,000 products and 1.5 million components are manufactured by Sealy in Australia every year, and these are sold through an extensive national and international network. Sealy International is also proud to have 12 world-first products to its name and remains one of Australia's most awarded manufacturers in this industry. With a proven track record of expertise, infrastructure, resources, we're ready to help to deliver on your next project. I'm going to hand over to Blair at the moment to talk a bit more about what drives energy-efficient HVAC solutions and how our advanced counterflow heat exchanger work.
Thank you, Leon. And welcome to all our customers tuning in. Great to have you with us. Our mission has always been bringing the latest technology and hyper-efficient HVAC to reality. and the CWX is no exception to this. Under this mission, we focus on research and development with our dedicated Imagineering team focused on blue sky technology, design and manufacture, particularly of our direct evaporative cooling units, as well as indirect evaporative cooling, and more recently our Dominator series, which is our reverse cycle gas replacement product. We also test and verify with our on-site NATA accredited facility. We also have an on-site laboratory where we research indoor air quality and other related subjects. And of course, service and support with our on-site service and support center, and also providing project suitability reporting through our applications engineers. We have sales engineers in each state as well as estimators and internal sales to help with day-to-day quoting and projects. So here at Sealy, we've always been known for making great evaporative coolers, gas heaters, and probably more recently, Climate Wizard. However, we also have a solid range of VRF under the Braemar brand, with a rooftop package soon to be added to that range from next month. So this gives us the ability to cater a solution to any application. So today we'll be mainly covering Climate Wizard. So to understand why Climate Wizard is such a game-changing product, we simply need to look at market energy trends and insights, such as the rising cost of energy, which is electricity has increased by over 60% between 2007 to 2017. But take into account recent increases, it's probably more like double that, with future increases likely as well. Peak demand has also become a major focus, and the cost of upgrading power infrastructure can be astronomical. And in terms of refrigerant regulations, there's always concerns on that front with HSC phase downs and phase outs that create a lot of uncertainty. So Climate Wizard solves all of these by using a natural refrigerant or water and requiring up to 80% less power to cool. So we're able to achieve such results through the revolutionary design of our counterflow heat exchanger. The heat exchanger is constructed of a series of alternating wet and dry channels. So if you imagine, hot air enters the dry channel where it is cooled prior to entering the indoor space. So a portion of this air, around 45%, is then redirected through the wet channel where the evaporative cooling process happens. This cools the walls of the heat exchanger and provides a cooling effect. The portion of air that enters the building has been indirectly cooled, so there's no moisture added. And in the process, any warm, moist air is then discharged out to atmosphere and not into the room space. So with the use of a psychrometric chart, we can clearly see how this process differs from your traditional evaporative cooling systems. So looking at a hot day, 37 degrees with a wet bulb of 19 degrees, on a day like this, an evaporative cooler would cool while also adding moisture at the same time, and typically get a supply temperature of around 22 degrees or about 85% wet bulb depression. But of course, during this process, there is moisture added, in this case, about 6 grams of moisture per kilogram of air. The way Climate Wizard differs is it's purely indirect evaporative. So as it's cooling, there's no moisture added, but we can also get much lower supply temperatures. So in this case, around 17 degrees with 110% wet bulb depression. And of course, during the process, there's no moisture added. So when comparing Climate Wizard to a traditional compressor-driven system for an extreme heat day, on a day like this, a compressor system's power input will increase significantly, but at the same time, there'll be a simultaneous drop-off in capacity. So the resultant drop in COP is quite drastic. Climate Wizard's power input on a day like this stays constant because it's only the fan power that's required, but we actually have an increase in cooling capacity because on these days, typically it's a fair bit drier. So the resultant COP is much higher on these days as well. So this is important because HVAC can account for around 40% of a building's total energy consumption. So having efficient air conditioning systems in the building presents a significant opportunity to reduce the overall building consumption. And as I've stated already, Climate Wizard can operate up to 80% more efficient, so lower costs, and typical return on investment on projects is typically under 5 years. So without further ado, I'll hand over to Danny to introduce the next generation of Climate Wizard product, the CWX and XR series.
Thanks, Blair. Thanks everyone for taking your time to come out today. We'll start off with a bit of a background on how the CWX came about. So the Climate Wizard CWX series was developed in response to a growing demand for HVAC solutions that not only deliver high performance but also integrate seamlessly with modern architectural aesthetics. Traditional rooftop HVAC units are often considered visually intrusive, particularly when viewed from street level or from surrounding high-rise buildings. Their bulky profiles, exposed ductwork, and scattered service connections can detract from the visual appeal from commercial and industrial developments. In addition to visual concerns, conventional systems often require complex installation processes involving multiple units, extensive ducting, and numerous service penetrations for power, water, drainage, and platforms. These factors contribute to increased project costs, longer installation times, and greater structural impact on the building envelope. To address these challenges, the CWX series was engineered with a sleek, low-profile stainless steel design and a self-supporting truss chassis. The result is a visually discrete, high-performance cooling solution that simplifies installation, reduces labour and engineering costs, and preserves the architectural integrity of the building. The CWX is an ideal for large-scale applications where both form, function, and space are critical factors. So going into applications and target markets for the CWX. Below we have a list of sports recreation facilities, gyms and training facilities, school halls, educational auditoriums, warehouse storerooms, industrial manufacturing, workshops, food processing plants, distribution centres, community centres, and trade retail centres. All these places have one thing in common. They're large open spaces which require high volumes of cold air at low pressure. Not only have we focused on these particular areas, but there are also plenty more opportunities, untapped markets, which are yet to be discovered. So now moving into some of the main features of the CWX and CWXR product range. So the CWX comes in either a single pass or a turn air model. As you can see in the top right is the CWX single pass. Bottom right, you have this CWXR return air circulation model. Both of these are low and slim profile, reducing your space requirements. Highly configurable units, so they come anywhere from an X2 range to an X8 range or an X4 twin range. Come with an integrated truss chassis design with supporting beam-to-beam installation. So this one in particular has been an interesting improvement for us in that this unit can be installed from end to end, and because it can support its own weight, it requires minimal roof penetrations for the mounting feet. This means that we can mount this up to 11.1 meters in length. So if you have a roof space which you would prefer to install your units on, and you are having a hard time speccing out the purlins for weight requirements, then the ideal option is that you can mount these straight from the beam to beam on the roof. Single service point connections, so throughout the whole range from the X2 to X8, they will come with one drain line, one water inlet, and one power inlet, minimising the need for running multiple connection points around the roof space. Built-in redundancy. So because these are made configurable, or essentially in modules that we provide within the units, any units that unexpectedly go down are then carried on by the remainder of the units to still provide cool air until there is until service can provide maintenance repairs for ongoing performance. Roof and ground mountable due to flexible ducting configuration. So we both have down discharge and a end discharge capability for supply air, specifically designed for low pressure ducted large open air space cooling. So again, in the previous slide, I spoke about the number of installation opportunities for this product. It's ideal for low pressure systems where you don't require large duct runs, and you can penetrate straight into the space for cooling. Common controls with integrated PLC. So each configuration in the range is run by a common electrical box with a common PLC, which is configured prior to dispatch onto site. So that leads for a seamless installation and integration into the building. Optional features. So another new feature which we've included into our Climeworks, in particular CBUX range, is the integrated walkway and mounting feet. And so the integrated walkway has come up as an idea because we like to see the smallest amount of time possible when installing an air conditioner on a rooftop. And so by having the opportunity to be able to install your walkway prior to dispatch, it means that your crane install can lower an entire package onto a roof with exceptional time, and can have it bolted down without multiple tradesmen coming onto site to continue on the job. So going into a little bit more detail of the spanning capabilities, above in your top left-hand corner is a side representation of the internal chassis within the unit. The total length that this has been spec'd out to is 11.1 meters. You can see on the both left and right-hand side, we have a safe zone for mounting feed points. This quantifies to 3.5 meters on either side. We do require, though, that structural assessments be undertaken for the building strength prior to installation. On the right-hand side, you can see one of our installs. This is CBUX4 Twin, which was installed on one of our sites. Here you can see the walkway that's been integrated into the system. And this was, we can speak about this more later, but this was deployed as one whole unit. So going into a little bit of the optional extras here. So below on the left-hand side, we have the walkway diagram. The mounting feet that will accompany this type of setup are usually installed prior to the lift. So all it will take is four mounting points, so 4 penetrations in the roof space, and a very, very simple fastening to the beams. Also, the walkway comes in a number of configurable sizes for any of the given configurations that we provide. So coming onto this page is our configuration page. As you can see, we have a vast number of configurations for these units. Here's a representation of what we have to offer. So for the X2 range, 3, 4, all the way going through to our largest range, we have single pass discharge options of being end and down discharge, and our return air, or CPXR return air model, we have up to four modes of which you could supply and return air back into the unit. So here's a quick overview of how the CBUX represents itself on a building installation. So as you can see here, fresh air is brought in through the side louver panels. That air is processed through the indirect evaporative cooling process, whereas once the cold air is created, it's down discharged into the building, and the remainder of the worked exhaust air is exhausted upwards into the atmosphere. So this is a little bit more of a detailed representation of the CBUX single pass version. So again, you have each of these, in this particular case, CBUX 4. We have 4 IDEC modules, indirect evaporative cooling modules. Fresh air is passed in through these modules where it's worked to become cold air. The percentage of that air which is doing the cooling and becomes hot humidified air is then exhausted upwards. And the majority remainder of that portion of air is then down discharged and supplied through the common plenum at the bottom, where it can either go out through a down supply or through an end supply. So this is a little bit of an overview of what CBUX will provide. So providing 100% fresh cool air, capable of free cooling, ventilation for smarter outdoor air usage by switching off all water supply to the IDEC core. Works in harmony with third-party heating solutions to further extend occupant comfort all year round. We have humidity control available on our multi-magic system, and we keep the indoor environment within ASHRAE standards. Here's an excerpt of some of the specs from our product range. Here we have airflows ranging from 2,700 to 11,000 litres per second at a standard 100 Pascal back pressure point. With our cooling capacities also ranging between 27 kilowatts to 109 kilowatts at standard testing conditions. So moving into the CBUX R series now. So the diagram below shows the CBUX 4R on a rooftop. You can see from the left-hand side, hot fresh air is brought in through the end louver. That mixes with the remainder of the recirculating air. So typically the ratio is a 70-30 split. So 70% of the air is recirculated and 30% of the air is fresh. These two air streams mix before they go in to the IDEC, the indirect evaporative cooling process, which then that brings that down the supply temperature to a fresh cool air point, where that's brought back into the building, and the remainder of the worked air is exhausted up into the atmosphere. As that air goes down, it's obviously worked by heat loads, and then once that air migrates across the room, cooling all personnel inside the building. It's then brought up back through the return air system, and the cycle repeats itself. So here's a side-on view of the CBUX. As you can see, only a portion this time is the fresh air, as we spoke about. The remainder of the return air comes in either through an end intake or an up intake. These two air streams both go through the indirect evaporative cooling process, which the worked air comes out and exhausts the atmosphere, and then the produced cold air comes down through this common internal plenum, and now it comes down through a down discharge or through an end discharge. And some of the main takeaways from this is it maintains consistent indoor temperature by blending return air with controlled amount of fresh air, reduces strain on compressors and fans, extending HVAC equipment lifespan and minimising maintenance. So this point taken here, I should elaborate. The CWXR can complement existing compressor systems very well, because it doesn't work in a single pass 100% fresh air system, so it doesn't expel the air that it produces. This means that you can potentially use these, or you can most probably use these in existing systems to help reduce the load of existing compressors, so you can maximize the use of the ClimateWizard technology while minimizing operational costs of existing components. We have enhances energy efficiency, as I just spoke about, and improves indoor air quality with integrated filtration. So the other benefit of this is that we're still living true to Sealy's, one of Sealy's ethoses, which is fresh air. And in this system, it's no exception. We still bring large amounts of fresh air in. So again, another excerpt of specs from the CWXR range. We have it ranging from an X2 to an X4 twin. Airflow ranges in between 1,700 litres. From 2,500 litres to 10,000 litres, with cooling capacity ranging between 24 and 96 kilowatts. So, having gone through the way our units work, thought we'd move on to some of the installations that we've undertaken. Now, these are just a few of the installations that we currently have, but they sort of explain a little bit of a diverse range of how they've integrated these units, and some of the colourful variations that they've exhibited. So first off is Basketball Stadium at Wayville Adelaide Showgrounds. So this was in collaboration with Basketball South Australia, and I've got to give a hand out to them because they've been fantastic in this process. They've really been on board and helped champion the CBUX from the beginning, and we've done our best to do our part to make sure that they've definitely got what they asked for. So the project expectations is that we provide energy efficient and cost effective cooling solution for comfortable conditions within the basketball arena. And we wanted to provide them with adequate fresh filtered air for the maximum number of expected patrons and players they would expect to get over their basketball season. HVAC units capable of fitting to a limited roof space. So in this particular case, they had a very slim working platform behind the back of their stadium, which didn't really
allow for many other products to present themselves forward as a suitable solution, and aesthetically pleasing as well. So it's, what you might know is that this backs onto a railway line, so you get daily commute from the back, and having something which was visibly aesthetic definitely brings out the vibrancy of a brand new basketball stadium. Sorry guys, that came a bit too quick. I think I'll, the next video I'll preempt you when it comes on. There's just one extra thing I thought I'd add, was the CWX, the CWXRs have potential for a reduction in up to 50% water savings, which you might have seen in that video, which I didn't mention in the previous slide. So yeah, just worth noting on that. If you do have any installations with water limitations or water restraints, then CWXR can definitely fill in a potential option for you. So here we go. So the outtakes from the Wayville Basketball Centre, we can go through a bit of performance specs. So we had total airflow of 39,000 litres a second as a standalone cooling application, with a standard supply temperature of 17 degrees based on the standard weather conditions in this particular region of Adelaide. Our cooling capacity comes out standalone at about 504 kilowatts, with an average COP during these conditions of 8.3. So what does that mean for the basketball stadium? Well, in comparison, if you had a DX system, you would have considerable power savings compared to a standard DX system. No more game day cancellations due to high temperatures. So this is an interesting one from Basketball SA. They brought in a new regulation recently. The regulation is anything above 38 degrees, then game days cancelled. So that was a big problem for them. That obviously meant that a lot of money would have been wasted by cancelling their game days. So a great alternative for them was to install a climate wizard to maintain more than comfortable conditions and bring that temperature down, so there was no chance of that occurrence happening. We've greatly improved the indoor air quality inside the courts, with CO2 levels well below what is considered acceptable levels.
So we actually had CO2 monitors put around the basketball courts, and what we found was that CO2 levels never rose to anything above what the industry standard calls acceptable. They were always ranging between ambient to say 420 to 500 parts per million. So they perform exceptionally when it comes to maintaining fresh indoor air. We have a reduced installation space, and it's aesthetically integrating. From the pictures over on your right hand side, you can see just how slimline and low profile it is. So this unit only reaches up to 1.7 meters in height, and it just means that from a long distance perspective, it doesn't seem overpowering to the architecture of the building. We also have a humidity control feature, which is brought on by our Multi-Magic. And this eliminates the potential for condensation on basketball courts. So one of the things that basketball courts can be susceptible to can be condensation. And because we're primarily driven by an indirect evaporative core with a booster from a direct stage, it means that we can pulsate the direct stage. So we can keep humidity rates well below a level at which we risk having condensation build up within the cores. So brings us on to our second case study. So Trinity College. So Trinity College is another interesting one, and I might just have a little story to start off with. So Trinity College was under a previous consulting team when the project was first conceptualized, and they were going to use different HVAC equipment for this job. And during that period, there was a change of hands between consulting teams to complete the job, and Sealy was given the opportunity to propose a set of HVAC equipment that could accommodate for the capacity needs and for the roof limitations. So the roof was, in my understanding, was designed around this initial HVAC equipment. And then when we got the job, it meant that some of our more traditional equipment didn't have the right footprint. But luckily, thanks to the configurability of the CWX series, we were able to tailor and adjust our cooler sizes to exactly fit the capacity required and also fit physically into the roof space. So with that, we also had to deliver a minimum requirement of fresh air in both heating and cooling, and provide an energy efficient and cost effective solution. And so this is the solution. So we had two CWX2R units with gas heaters on the front end in line, and one CWX3 with a gas heater on the front end. These gas heaters were just the heating elements. Their air was powered by the CWX fans. So with the building management system they had in place, they were able to run the CWX as required, and they were able to use the fans from the CWX to power the gas heaters as required. They were also installed with dampers on the back end, so they were able to run it as a 100% fresh air system or a recirculated 30% fresh air system. This meant that they could maintain indoor comfort and air quality while minimizing the amount of power that they consumed. So just going down some of the project benefits, both heating and cooling were supplied by the same ducting and fans, so we minimize the amount of ducting. Temperature and humidity were controlled throughout the entire year, and sufficient levels of fresh filtered air were introduced to improve the indoor air quality and greatly reduce CO2 and VOC levels. And I put in brackets there. There are a number of studies which do directly correlate children's improved learning ability with lower CO2 levels. So for a school, I think this is a really point to point out, and it might be something that gains a lot more attention in the future. And so we're going on to the last but not least. So this is the indoor sports stadium here at Morphettvale Vale in Adelaide, South Australia. It's an indoor cricket centre, but it also serves as an inflatable world children's playground. So their need for cooling was paramount. All these indoor inflatable castles need fans to keep them inflated. They all of them don't run completely efficient, so they all produce a lot of heat. It's also inside of a tin shed. So the heat loads were very significant for this place, and our mission was to provide a cost-effective installation while bringing the air down to a reasonably comfortable level. So this place was very large. I believe it was like 70 meters by 35 meters, and we only one cooler for one side of the indoor sports centre was selected for cost effectiveness purposes. So we found it incumbent on us on how we could provide a solution which would minimise the capital cost of installing multiple units, but also maximise the indoor air comfort. And so one of the ways we went about that was to implement a displacement cooling strategy. So to target cold and effective area of activity. So it was the first 2 meters of height everyone runs around with. The above 6 meters of heights not applicable to cool. So we came up with a strategy, and the strategy was to cool using displacement. So we ran a series of false cavity walls and a series of porous socks in which we delivered the air at very low speed. And that seemed to not only cool the desired side of the indoor sports centre that was initially allocated for, but that cold air also migrated across to the other side, also relieving, also bringing down the air temperatures and cooling the occupancy over on that side. So this was brought on by a single lifter unit, including walkway to reduce time and installation and downtime of business activities. Sorry, I thought I'd mention there's another video coming on. Right. So that was the CBUX4 twin lift and install on the indoor sports center. So we used one unit. This was, as you could see, had the integrated walkway installed onto it prior to lifting. So a notable mention upon receiving this unit at site to installation and fastening down, it took about 45 minutes to complete that process. So we're very impressed with that, and we're very pleased, because that was one of our criteria by including all this equipment into one package, was that we could minimize the amount of time to install on site. So that came out very well for us. This unit provides about 9,600 litres per second of air, with a standalone capacity of 116 kilowatts and a COP of 7.8. The way they've benefited is that they get fresh cooled filtered air provided all year round as required. Their displacement cooling has enabled them to maximise the amount of cool air around their indoor sports centre, while minimising the amount of total capacity traditionally required, and the install time from the consultants. So everyone benefited from this package. And upon saying that, that closes up what I have to say about the CBUX product range, and then I'll bring it back to Leon now for any feedback and questions he might bring forward. So thanks, guys. Thanks for listening.
Thanks, Danny. Really appreciate that insight to the CWX and XR. We have a few questions to answer. I think let's start off with the first one, is the CWXR unit. What is the reason for the additional water saving on a CWXR compared to the CWX?
I might let Danny answer that one.
Yeah, no, that's no worries. That's a good question. So the reasoning behind that is typically with a single pass, it's air's brought in at 38 degrees, and then you process the air and you cool it down to whatever the leaving temperature may be. But in the return air case, you're not bringing in 38-degree air. You're bringing in the leaving air from the room. So in a standard setup, you'd call that, say, 27 degrees. So because you're bringing in air of a temperature half that of what the standard air outside would be, therefore you're only using half the amount of water to process that air down to its supply air, cold air temperature point.
Thank you very much, Danny. Another question would be, can the XR unit be used in a standalone application?
Yep, because so the indoor sports centre was a standalone application, and so yeah, that's an example of how the return air version can be used as a standalone product.
Right. Thank you very much. I have one other question, and that's to do with the unit. Can a DX unit be fitted to the CWX as well as the XR, or just one of the units?
Yeah, I can fill that question.
That is, we talked about, I think the question comes from, it's an integrated at the Trinity College on a XR, but where we have a gas heater on it. But can you integrate a DX unit in place of the gas heater, as well as can you integrate a DX unit on a CWX alone?
Yeah. So yes, you can. So in the case of Trinity College, you could definitely replace the gas heater with the DX system, and you can get it to perform in the same configuration. That's not a problem.
So I might just add to that if I can. The key to that application would be controls as well. So at the moment, I think Denny is working on making the units controllable through Modbus, and for future, I think that will also include a BACnet option as well. So that will give the ability to apply a third-party control system to work in conjunction with the Climate Wizard and also any third-party DX system or coil that might be attached to it.
Thanks, Blair. Thanks, Danny. That seems to be all of it. Oh, wait, just see there's another question came in. Is there a direct loss in efficiency if the wet bulb temperature is 22 degrees rather than 19 degrees, with the latent rise by, say, 3 degrees Celsius?
So I'll answer that one. So the supply temperature would change. Obviously, it's dependent upon not just the wet bulb temperature, but the dry bulb as well. If we're looking at the condition we had before, where it was 37 degrees dry bulb, 19 degrees wet bulb, if it was simply 37 degrees dry bulb and 22 wet bulb, we'd still be able to get at least 1 degree below the wet bulb. So we should be supplying around that sort of 21 degrees for that application. So yes, there is a slight drop in performance, but still overall, the temperature reduction is still significant, and we can still get below that wet bulb condition.
Thanks, Blair. Do we have data for other regions?
Absolutely. So the best thing to do is, if you've got a potential example, just get in touch with either one of our sales engineers or myself. There's an email address down the bottom there, commercialsales@sealyinternational.com. Send it through to that. Give us some details of what region you're looking at, and just a few minor details about the application, and we can provide a tailored selection for that zone, and include the performance in terms of supply temperature, capacity, COP, and we can also do full energy consumption comparisons as well. So if you want to compare Climate Wizard with a DX system or other, we can tell you throughout the course of a year how much you'd actually save in energy from using Climate Wizard over the other system.
Lovely. Thank you very much. And Danny, what is the weight of the units, sort of a starting point to sort of from a X2 to an X8 or a X4 twin?
So off the top of my head, I believe an X2 weighted with water comes in at about 900, and then an X4 comes in at about 1700, and so an X4 twin will come in at 3400 kilos.
Thanks. We also have a question on price. What is the cost of the units?
Yeah, so I can take that one. We typically do it on a project by project, because first and foremost, we like to make sure that it's fit for purpose. So once again, just give us a few details about the project, and we can provide a full selection, and part of that we'll also advise the cost, obviously how many units you'll require and any specific controls that would be applicable as well. We can put that all into a package and provide it. So once again, just send it through to that commercial sales email you can see on screen, and we can help you out with that.
Thanks, Blair. And then, have we installed any other units in Queensland? I know that we've done New South Wales.
Yes, no X models as yet. So obviously this is a new launch product for us, but we do have a number of CW80 projects we have done in Queensland, probably most notably the Golden Circle Cannery, where we supplied 4 of our CW80 S units that were supplying around about 7,000 litres per second each, and sort of like a standalone or spot cooling application for that zone. We also have the Bundaberg Brewed Drinks factory, which was installed a couple of years ago, similar sort of application, and 2 CW80s on that site. Probably have 7 or 8 other similar sort of sites spread throughout Queensland as well.
Excellent. Thank you very much, Blair. the XR unit, does it reduce the humidity within the space, being a return air unit?
Yes, so I'll take that question. So it does. So one of the differences between the single pass and the return air model was that the single pass does work with the direct state boosters, which do slightly increase the humidity within the airstream. The return air unit, because of the way it's designed and because of its configuration, means that it has to run solely on indirect only. However, the supply air temperature is not affected because of the fact that we're bringing in temperature that is on the standard conditions, say half of the temperature of what would be outside. So there is an improvement, being that we don't add any moisture to the airstream.
Lovely. Thanks, Danny. I think that's all that we have time for at the moment. We'd still definitely like to get your feedback regarding these products. For any product updates, if you're interested in joining Sealy for a face-to-face formal site visit, please let us know. Send your request through to commercialsales@sealyinternational.com. Should you have any projects you think is suitable or want our applications engineer to create a suitability report for you, or want a lunch and learn at your office, once again, please just reach out on that email address and request that through commercialsales.com. So just lastly, please remember to complete the short survey, and thank you for attending. It is sincerely appreciated, and we are looking forward to engaging with customers in future projects. Have a great day. Thank you very much. Bye.
Thanks, everyone. See ya.
Thanks, guys.